Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will introduce equations. An equation has an equal sign. And we're also going to look at special types of an equations called a rule or formula. So, a rule or formula is an equation, so it has to have an equal sign. It has two or more variables or pronumerals, two or more letters, and one of them must be the subject of the equation. So, subject just means the thing that's by itself. So, let's say we have the equation y equals x plus 1. That is an equation because it has an equal sign. So, the thing that's by itself on one side of the equal sign, we say that is the subject. So, y equals x plus 1 is an equation because of the equal sign, but it's also a formula because it has more than one variable. It has two variables or two pronumerals, and one of those variables is the subject of the equation. So if I have something like just x minus 7, that is not an equation. There is no equal sign. Remember, we call this an expression. It's an expression with two terms. X is a term, minus 7 is a term. So this one can't be a formula because a formula is a type of equation. So it's easy to tell whether or not something's an equation. You just look at whether it has an equal sign. To tell whether it's a rule or formula, you have to find the equal sign, but you also have to count the number of pronumerals. There has to be at least two. And one of those pronumerals, one of those letters needs to be by itself on one side of the equal sign. That's what a formula is. So these two things here are both equations because they both have an equal sign. This one here is a formula, f equals ma, because f is the subject of the equation. F is the subject because it is by itself. So here, f equals ma, we have three variables, and one of those variables, one of those letters is the subject. That's why that's a formula. But this thing here is an equation because it has an equal sign, but it is not a formula. Now, it does have more than one variable. It does have two or more variables, x and y. So two or more pronumerals is right, but neither x nor y, none of the letters are the subject of the equation. Here, 4 is the subject of the equation. We don't have a letter by itself, therefore it's not a formula. So after we understand these definitions, what we're going to do is move on to solving equations. You can only solve an equation when you have just one variable or one pronumeral. So we're now going to look at solving an equation. You can only solve an equation when there's one pronumeral. And when we say solve an equation, we mean find a value that you can substitute for that pronumeral to turn the equation into a true statement. Let's start with a really easy equation. X plus 1 equals 8. So this is an equation because it has an equal sign. It's not a formula because it only has one pronumeral, and formula need at least two pronumerals. So this is an equation with one pronumeral, so we're going to look at solving it. So when I say solve it, I'm saying what value can I change x for? Can I substitute for x to make this a true statement? So of course the answer here is x equals 7. That is the solution. That is the number that solves this equation. The reason x equals 7 is a solution, if I substitute x equals 7 into the equation, I get a true statement. So let's start with the equation x plus 1 equals 8. If I rub out x and change it for 7, this is a true statement. 7 plus 1 equals 8 is a statement. It is true. Now, there are no other solutions. There's no number other than 7 that I could substitute into this equation to make it true. Let's say x plus 1 equals 8. If I substituted, say, the number 6 into this equation, I would get 6 plus 1 equals 8. That is not a true statement. So x equals 6 is not a solution because if I change x for 6, I get a statement that is not true. And that's what we're looking for when we're solving equations. A number we can substitute for a pronumeral that will make the statement true. So for many equations, you'll be able to tell the answer off the top of your head. If I said x minus 3 equals 9, well, that's easy. You know what number when you subtract 3 gives 9? It's 12. Because if I put a 12 here, 12 minus 3 equals 9 is a true statement. So x equals 12 is the solution, and it's also the only solution. So if you couldn't see the answer off the top of your head, what you can do is you can do the opposite of this operation. The opposite of minusing is plussing. So to find the answer, instead of minusing 3, I could go 9 plus 3, which gives you 12. So let's say I have the equation 4x equals 48. Now, no, x doesn't equal 8 here. Remember, this is saying 4 times x equals 48. So what number do you times by 4 to get 48? The answer, if you don't know, you can undo timesing by 4 by dividing by 4. So just like subtraction and addition undo each other, multiplication and division undo each other. So to find the answer here, I can go 48 divide 4. Instead of timesing by 4, which is what's happened to x, I can go 48 divide by 4. That undoes timesing by 4 and gives me the answer x equals 12. Most of you could probably get that off the top of your head anyway. So the answer is 12 because 4 times 12 equals 48 is a true statement. So you can solve these equations we're doing in this lesson either off the top of your head or by using the opposite operation. If you get something like 10 minus x is equal to 1, you're just saying, what number do you subtract from 10 to get 1? And you probably know the answer's 9. If I subtract 9 from 10, if I change x to 9, I get a true statement. 10 minus 9 does equal 1. Now, if you have something that looks like this, remember that the fraction line here means divide. This is saying x divided by 3 equals 6. So what number when you divide by 3 gives you 6? You can probably get the answer off the top of your head. It's x equals 18. Because if I substitute 18, I get 18 divided by 3 equals 6. That is a true statement. If you are unsure here, what number when you divide by 3 gives you 6, do the opposite. So instead of dividing by 3, go 6 times 3, which is 18. So we're going to solve heaps and heaps of equations in this section of the course. And I really need to make the point that sometimes when you solve an equation, the answer is not a whole number and it's not always positive. So let's say I have 2x equals minus 7. So if I want to find what value I can substitute for x here, it won't be a whole number and it will also be a negative number. So if you don't know what it is just by looking at it, go minus 7 divide 2. This is 2 times x. The way we undo timesing by 2 is dividing by 2. And minus 7 divided by 2 is minus 3.5. That is the solution because if I substitute x for minus 3.5, I get a true statement. 2 times minus 3.5 does equal minus 7. And again, that's the only solution. All of these equations have only one solution. So sometimes the solution will be negative, sometimes won't be a whole number. That doesn't mean you've done something wrong if your answer's not a whole number, because not all answers will be whole numbers. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.